Hello everyone. In this video, we will continue to work with integral of transcendental function. So for this particular integrand, I would like everyone to take a look at secant square of x squared. So remember I mentioned in previous video, whenever you have a square, then what you need to do is you need to check your formula sheet. Okay, if you have an exponent for your trig function and if it is a square, then you immediately check your formula sheet. So what I will do is we go back and take a look at our formula sheet here. So what do we see? We are seeing that there is a formulas for secant square, which is right here. See secant square? So whenever you see a secant square, that means you probably be able to apply these formulas. Then what do you have to let u equal to? So u has to be the argument of this trigonometric function. Okay, so before in previous example, what you do, you see that cos to the exponent a half, right? So there isn't any exponent a half here. So if you have cos exponent half, then you have to let that cos equal to u. But in this case, you have a trig function, but it's raised to the exponent 2. So you might as well use the formulas. And what is your u will be? Your u had to be the argument of this function. So if we go back to our example, okay, if we go back to our example, we will see that we can go ahead and apply the formulas for this. Okay, so if you let u equal to x squared, let u equal to x squared, okay, so what do we have? We have secant square of x squared times x dx. So you may want to bring the x to the back and multiply with dx. And you know that the x dx is somehow that you have to match it so that you can pull out the du factor. So in this case, what is the derivative of u? Equal to x squared. So du over dx equal to the 2x. Okay, so that means du over 2 equal to x dx. Very simple. Alright, okay, so this is very simple. And I can see that I already match my differential factor, x dx. So now what I can write is the integral of secant square x squared. I already let that equal to u, so I put the u. And what is x dx? Now I can write it as du over 2. So the differential factor match as a du, and my argument is also in terms of u. So I will bring a half across the integral sign. And here I have secant square of u du. So that I can go ahead and apply that formulas. Okay, so what is the formulas for the integral of secant square u du is equal to tan of u plus c. Okay, equal to tan of u plus c. Okay, so let me rewrite this. Okay, so I have the integral of secant square of u times du will become tan of u. Okay, so let's double check. Alright, okay, sorry I moved back and forth between the two documents. So you can see that right here I have these formulas that I have to work with. So integral of secant square u du become tan of u plus c. Alright, okay, so let's get back to our example. So I have it equal to a half tangent of u plus c. But I must replace the u by the x squared because I let that equal to x squared from the very beginning. So tangent of x squared plus c as the final answer. Okay, so this simple. So why do we do this example when it's just simple like this? Okay, the reason I throw this in is because remember earlier we are working with these formulas, or we are working with this integrand. You have cos raised to exponent a half, and there isn't any formulas that involve a trig function raised to the half. You have a trig function raised to the exponent 2, but in this case you must let this cos equal to u. Okay, cos x equal to u. But in this case, what you have, if you have secant square, and you already have the formulas that involving the secant square, therefore you are going to let the argument of the secant equal to u. Okay, so you can apply these formulas. Alright, so let's go to the next example. Okay, so I would like to write a quick rule here for everyone. Okay, so I would ask everyone to check formula sheet. Check the formula. Okay, then we saw that we have the integral of secant square u du. Okay, so therefore we have to let u equal to x squared. So that's the hint that I would like to give everyone. Alright, so let's move to the next example. For this one, okay, so now you see you have secant square of x. Here you have secant square of x squared, and then you let this x squared equal to u. So in here, you probably ask me, do I let this x equal to u? If you let x equal to u, then du equal to dx. There isn't anything else you can do after that. But you see there is a function right here, square root of this function. So if you rewrite this as the exponent, what do you see? Okay, if I rewrite this as the exponent, I can write it like this. Alright, so I can write integral of anyway, I will write it here. So the integral, you can bring 2 across the integral sign. You write 1 plus tangent of x, all of it to the exponent a half, then secant square of x dx. Alright, so if you have a function raised to a power, then you have no choice. Okay, you must let that function equal to u. If you let this function equal to u, so I will let u equal to 1 plus tangent of x. Okay, so you see right here, I should have u raised to the exponent a half. Okay, I should write a 2 here. Now I must multiply this with something in terms of du. Okay, so that du coming from the differentiation of this u right here. And what is the secant square x dx? Help me with, because derivative of tangent of x will involve the secant square of x. So let's go to our formula sheet. So we keep going back and forth between the formula sheet because I would like to show everyone how to use this 2 formula sheet. So what is the derivative of tangent of x? In this case here, derivative of tangent of u will be secant square of u multiplied by du over dx. This formula number 3. You can apply these formulas to the differentiation of 1 plus tangent of x, and then somehow you will review the differential factor that you can match the differential factor with the du. Okay, so now if I take derivative of u, then I should have du over dx. What is derivative of 1 is equal to 0. What is derivative of tangent of x is the secant square of x times derivative of x. Derivative of x is just 1. Alright, so then I will have du equal to secant square of x times dx. Alright, so I'm done. I'm going to circle this, and now I'm going to match this secant square of x dx exact equal to that. Therefore, now my integral becomes 2 u to the exponent a half, and then in this case it's just du. You see, instead of writing secant square of x dx is equal to du here, so I just write it as du. So what is the integral of a half? U raised to the exponent a half, so we just add 1 to the exponent. So as 1 to the exponent, a half plus 1 is 3 over 2. Okay, a half plus 1 is 3 over 2. Divided by 3 over 2, that means I multiply by 2 over 3. Okay, this one plus c. Let me correct this so I make sure I write 2 here. Then what do I have as the final answer? 4/3 u to the 3 over 2 plus c. So I can write as 4/3 1 plus tangent of x raised to the exponent 3 over 2 plus c as the final answer for this integration. Alright, okay. So again, you see that the strategy that I ask everyone to apply, the general rule for that, it should work. As soon as you see a function raised to a power, what you need to do right away is you have to let that function equal to u. Okay? So you see a function raised to exponent a half here, then immediately let this equal to u. Okay, so that's our question number 6. Let's move on to question number 7. Alright, so question number 7. Okay, so what do I do in this case? I have the integral of 2 times cosecant is 1/3 of x dx. So you see, you are going to the formula and see what you have. Okay, on the formulas of integration, you see that there is a formula for cosecant of u du. It's right here. Integral of cosecant u du will be natural logarithm of absolute value of cosecant u subtract cotan of u plus c. So it's very simple. So in this case, you are going to let the argument of cosecant equal to u. Okay, so what I have is I am going to let u equal to 1/3 of x. Then what do I have? 2 cosecant of u, right? So I need to multiply by something here. I don't know that yet. I have to figure it out by taking derivative of this. So this will become 1/3. U equal to 1/3 of x, derivative of u should be 1/3. Then I will take 3 times u du and dx times 1. So I match this dx with this dx. So now I just have to write 3 du, right? So here I should have integral of 2 cosecant of u times 3 du. Bring both of this across the integral sign. I should have 6. 3 times 2 is 6. Okay, so cosecant of u du then let me circle this because I complete this already. Okay, so what is the integral of this cosecant u that I've shown everyone earlier, that it will become the 6 times natural logarithm of cosecant of u subtract cotan of u close absolute value plus c, and I should replace this by cosecant of 1/3 of x subtract cotangent of 1/3 of x close this absolute value plus c. So this is my final answer. Okay, sum is actually quite simple. By just apply the see what formulas that you can apply for this. There's a formula for cosecant, so this argument of cosecant will become your u. Alright, okay, so let's move on to question number 8. Alright, so question number 8, again I have the cos, okay, cos of this argument times dx divided by x to the exponent 3. So let's go to our formula sheet again. So for our formula sheet, I see that there is a formula for cos. This is this formula. Integral of cos u du equal to sine of u plus c. So your the argument will become your u. Alright? Okay, the argument will become u. So in this case, the u that you are going to figure out is the argument of your cos. So in this case, what we have is we are going to let u equal to 1 over x. Okay? So you may want to rewrite this just to be okay. I believe that I make an error in typing this. I would like everyone to fix it for me. So this should be x squared. Okay, x squared. Okay, I should have x squared. On my solution is an x squared. So I would like everyone to correct that for me, please. So this should be an 1 over x squared. Okay, so I am going to rewrite this to make sure that we are clear with that. So it will be the integral of cos of 1 over x squared multiplied by dx divided by x to the exponent 3. Alright, okay, so we are going to let u equal to 1 over x squared. So that means x to the negative 2. Then du over dx is equal to negative 2 times x, and that will be minus 1 will be x to the negative 3. So it has to be x squared in order for us to integrate. It's just a typo right here. If you can correct that for me, 1 over x squared. Alright? Okay, so in this case what we have is I will write it as du over negative 2 will be dx divided by x to the exponent 3. Okay, so or I can write it like this. Okay, so now I have this matching this exact one, and I'm done with my differentiation and manipulation of the ratio. So what I have here, I will write it as the integral of cos of u, and then I will write that as du divided by negative 2. So bring this across the integral sign. I should have negative half, and cos of u du. Apply the formulas for this. What is the integral of cos? The integral of cos is just sine. So this is just sine of U plus C. So I will rewrite this again as sine of 1 over x squared plus C as the final answer. Okay. Alright. Okay. So in this case, you see you have the integral of cos. Integral of cos equal to sine. So what you need to do is you need to let the argument of cos equal to U. Okay. Now, so move on to the next question. The next question I have here is 2 minus cos of x divided by sine of x. So you have both the cos and the sine. So let's go to our formula sheet to see what we can do with that. So I come here and I try to look for the formulas. This is sine, cos, secant, cosecant, and I don't see anything involving sine over cos or cos over sine. But then I know that I can use some sort of trig identity. Okay, I can use trig identity. So where do we find trig identity? We find trig identity on the other formula that I gave you. So you can see that if you have sine over cos, it becomes tangent. Okay? So if you have cos over sine, it becomes cotangent. Okay? So let's go back and see what we can do with that. So in this case, what you have to do is I will break this into two integrals. Okay, I will break this into two integrals. I will have 2 divided by sine of x dx subtract cos of x over sine of x. So you break this into basically what you have done is you go like this. Integral of 2 over sine of x subtract cos x over sine of x. Alright. And then you break that into two integrals. So you break this into two fractions first because you have the same denominators, right? And then you break that into two integrals. So from this integral, I know that I can bring this across the integral sign. So I will have 1 over sine x dx. Okay, here I have cos x over sine x dx. Okay, so then I need to apply trig identities. What is 1 over sine? 1 over sine is cosecant. So 2 integral of cosecant of x dx. What is cos over sine? The trig identity is equal to cotangent. So integral of cotangent of x dx. And there are formulas I can just apply for this. What is the integral of cosecant? And what is the integral of cotangent? Okay, so let's go to our formulas. Integral of cosecant. So I need everyone to review your trig identities, alright? Trig identities, 1 over sine equal to cosecant. Sine over cos is equal to tangent, but because tangent is the inverse of cotangent, therefore you have cos over sine will be equal to cotangent. Okay. Then what formula can I use? I use the integral for cosecant. What is the integral for cosecant in this case? Integral for cosecant, where is that? Yes, right here. Integral for cosecant is natural logarithm of cosecant x u subtract cotangent of u plus c. And what is the integral of cotangent? I found it right here. It's the ln of absolute values of the sine. Alright. So you are using formula number 10 and you are using formula number 12. Okay? So what I can write here is I can write is as this will become 2 times ln of cosecant of x subtract cotangent of x, close the absolute value, subtract natural logarithm of sine of x, close absolute value plus c. Alright, okay, so this particular example, you have no fast rule that you can apply. Okay, you cannot try to find let 2 minus cos of x equal to u. Okay, so if you do that, you can differentiate, but don't forget this is divided by sine of x. Okay, you divide it by sine of x. So if you chose to just let, okay, I let 2 minus cos x equal to u. So what is derivative of minus cos x? This is derivative 2 equal to 0. Derivative of cos is equal to what? Sine. Okay, so let me review for everyone. Derivative of cos is equal to sine as a negative. But then, doesn't matter what you try to do. You cannot manipulate it to have the dx divided by the sine x. Okay, you must have sine x multiplied by dx somehow in order to match the differential factor. Therefore, you cannot work with this by let u equal to 2 minus cos x. Okay, so I can quickly write it for everyone. So let's say, but I will erase this in a minute. Okay, let's say assume that we 2 minus of cos x equal to u. Okay, so what is du over dx? The derivative of 2 is equal to 0. For the derivative of cos is negative sine. So then you should have negative sine times negative, so which could be plus sine of x. And then you will say du equal to sine x times dx. But here you have, here is your dx divided by sine of x. So no way that you can try to match this with this. Okay, so that's why this method will not work at all. So when it doesn't work, what do? You break this into 2 integrals and then you apply the trig identities. Okay, so let me erase this. So it's a very good analysis anyway, right? Good analysis. If it doesn't work, we have to try something else. Okay, yeah, very good. All right, so I believe that I think I will leave question number 10 and question number 11 for my next video. Thank you.